name is Shreya. I'm studying in Sri Venkateshwara College of Engineering. Today I'm discussed about the subject applied chemistry. In that topic, nanomaterials. Contents: Introduction, synthesis of nanoparticles, size dependent properties of nanomaterials, nanofibers, properties of nanofibers, applications of nanofibers, nanophotonics, properties of nanophotonics, applications of nanophotonics. Introduction. The prefix of nano is derived from the Greek word of "daf". 1 nanometer is equal to 1 billion of meter. Generally, nanomaterial size between 1 to 100 nanometer. A human hair is approximately 75,000 nanometer width and red blood cell approximately 5,000 nanometer width. What is nanomaterials? Nanomaterials are cornerstones of nanoscience and nanotechnology. The nanomaterials is a interdisciplinary science involving chemistry, physics, material science, biology, engineering, and medicine. Interdisciplinary technology. Nanotechnology, engineering, biology, chemistry, physics, medicine. Synthesis of nanoparticles. Top down approach, bottom up approach. Top-down approach. Top-down approach refers to slicing or successive cutting of bulk materials to get nano-sized particles. Bigger materials are broken down into small nano-sized materials by means of various physical methods. But these approaches as limitation like these methods requires the expensive apparatus. Bottom-up approach. The bottom-up approach is refers to building up of materials from their bottom, atom by atom or molecule by molecule or cluster by cluster. Generally, bottom-up approach is more advantageous than top-down approach. The main advantage of a bottom-up approach is in producing nanostructure with less defects and more homogeneous chemical composition. Size independent properties of nanomaterials. Surface area. Many particle and chemical properties of a materials depends on its surface properties. If a bulk materials in a subdivided into individual nanomaterials, the total volume remains the same, but the collective surface area is greatly increased. Example: the collective surface area of a cube is 6 m square. If this cube is progressively cut into smaller and smaller cubes, the surface area will increase to 6,000 kilometers square. This surface area is enormously increased on moving from bulk to nanoscale. Bulk materials in subdivided into individual nanometer materials, but the collective surface area is greatly increased. Electrical properties. The metal which are good conductors in bulk become semiconductor and insulator, and their size is increased to nanoscale. The electronic bands in a bulk materials are continuous due to a overlapping of orbits of billions of atoms. But in the nano-size materials, very few atoms or molecules are present so that electronic bands become a separate. Thermal property. As the size of the nanoparticles decreases, the atoms are surrounded by lesser number of atoms, which results in the increase in surface energy and decrease in melting point. Nanoparticles compared to bulk materials. For example, bulk gold melts at 1064 degrees Celsius, but the melting point decreases considerably as the size decreases as shown in figure. 5 nanometer gold nanoparticle melts at 700 degrees Celsius. Catalytic properties. The catalytic property of a materials depends on a particle size. If the size of the particle reduces from the bulk to nanoscale, surface area increases. That leads to very high catalytic activity of the same material. Example: bulk gold is catalytically inactive, but gold nanoparticles are catalytically very active for selective redox reaction. Nanofibers. Nanofibers are the fibers with a diameter varying from the 1 nanometer to 1 micrometer. Nanofibers are prepared from a different natural and synthetic polymers. Most commonly used natural polymer to prepare nanofibers are keratin, collagen, silk, fibrion, cellulose, gelatin, and polysaccharide such as and keystone. Nanofibers can be prepared by a varieties of methods like self-assembly, electrospinning, template synthesis, and phase separation. Diameter of the nanofiber depends upon the polymer source and method of preparation. Nanofiber properties: high surface area, highly porous in nature, high strength, high flexibility, excellent mechanical properties, having a light weight with a small diameter. Nanofibers have attracted a great deal of attention due to their remarkable properties. Assemblies of nanofibers have porous structure with excellent pore interconnectivity. They have a high surface to volume. Application of nanofibers used in biomedical applications like drug delivery system, tissue engineering, etc. Used in environmental applications like water filtration, air filtration. Used in energy applications like batteries, supercapacitors, fuel cells. Used in textile applications like sportswear, clothing manufacturing. Used in electronic applications like production of sensors, electronic devices, flexible display, etc. Used in high absorbing diapers. Nanophotonics. It is branch of nanotechnology that deals with the study of behavior of light on the nanoscale. Properties: enhancement of light matter interaction, precise control of light, having high sensitivity, occupy less energy, high dense data storage. Applications of nanophotonics: used in sensing and detection applications, used in diagnosis, used in imaging applications, used in photonic non-display applications, used in energy conversion application, used in optical communication application, used in quantum information processing. Thank you.